In the review problem at the beginning of this section, we looked at the derivative of a function that required a chain rule here. And once we found that derivative, we ended up with x squared plus 2x plus 5 to the fifth power times the quantity 2x plus 2. So what I'd like to do in this section, in this first example, is to go backwards here, is to show if we take the antiderivative or the indefinite integral of y prime, we should end up with the same, or at least a very, very similar function to what we began with. However, this function right here is going to be a little bit more difficult for us to integrate because we're going to have to use a new integration rule. We're going to have to use something called integration by substitution, or sometimes it's called the substitution method, or sometimes it's called U-substitution. It's got a lot of names. But it should feel very, very similar to the process that we outlined with the chain rule. So we're going to go ahead and integrate this same function now. And what we're going to start with here is we're going to start by choosing an inside function. And we're going to think about this actually very similarly to how we thought about the inside function for the chain rule. Generally, it's going to be the part that is the highest power of x. It's kind of the, quote, most complicated part right here. And I'm going to call that function u. So I'm going to take this piece right here to be my u. So u, I'm going to call x squared plus 2x plus 5. So that's just my first step, is just picking out that inside function. My second step then is to find du. I need to find something called the differential, which you don't need to know exactly what that is for right now, but we're just going to find du, and the way we find that is taking the derivative of what came above it. So we're taking the derivative of this x squared plus 2x plus 5. So that would give me 2x plus 2. And then I multiply that derivative by dx, because what I'm going to be doing here is I'm going to take this integral, which is originally written in terms of x. I'm going to rewrite it in terms of u. And that means changing all of my variables, including this dx. I need to get rid of all of the x's that we see there. So that is going to be my du, and I'm hopefully going to line up that du with other parts of the integral. And if I look right here at this 2x plus 2 times dx, well, that matches exactly what I have over here for my du. That is just 2x plus 2. So that means that that part would be my du, and then we already decided what our u is. That's the x squared plus 2x plus 5 to the fifth power. So if you need to, step 3 is to solve for other parts of the integrand. We don't need to do that here. We'll see some examples in the next page where we do have to do that. And it's usually the case where we'll have to do a little bit of multiplication or division. But in this case, the substitution works out really nicely. So I'm going to rewrite now this integral entirely in terms of u. So instead of having x squared plus 2x plus 5 to the fifth power, I'm now going to have u to the fifth power. And then instead of having 2x plus 2 dx, well, we said I can take out that whole thing and just replace it with du. So this is really u to the fifth power du. If the colors are distracting, maybe we can rewrite it. We can say that this is really u to the fifth power du. And the whole point of integration by substitution is to take an integral that is difficult, so this is a fairly complex integral, and we're going to break it down into smaller pieces, and we're going to make it easier to work with. So the integral we started with had a lot of x values. There's a trinomial, there's a binomial, there's a lot going on here. But when I look at this, the indefinite integral of u to the fifth du, well, that's just going to be a regular old power rule. So my power rule says we add 1 to the power u to the sixth, divide by that new power of 6, even when we use this new u substitution, we're still going to be adding our constant of integration c. And then for our very last step then, if I started with something in terms of x, well, I'd like to end with something in terms of x, which means I'm going to take the expression for u and I'm going to plug that back in. I shouldn't have any u's in my final answer here. So when I go and rewrite my problem, we said u to the 6th is really x squared plus 2x plus 5 raised to the 6th power divided by 6 plus c. Let me clean that up a little bit. And there is our indefinite integral. There is our general antiderivative. Now let's check our answer really quickly before we wrap this video up. Hopefully the antiderivative that we found here, x squared plus 2x plus 5 to the 6th power divided by 6 plus c, hopefully that matches what we began that review problem with. And if we look, we had x squared plus 2x plus 5 to the 6th power. Here we're multiplying by 1/6, but multiplying by 1/6, this is the same thing as dividing by 1/6. I could pull this apart and I could say 1/6 times x squared plus 2x plus 5 to the 6th power, just so we could see that similarity. The one really big difference that we do have here is in the antiderivative that we found, we've got plus c, and in the function that we started with, we've got plus 7. So we did lose that constant along the way. Unfortunately, unless we have an initial condition or unless we have a point that's on our graph, we can't really know the exact antiderivative that we're talking about right here. The best we can do is this general antiderivative. So we're going to be practicing this new integration technique called the substitution method a lot in this section. I do think you really want to get some practice in with it. It is a section, it is a technique that students tend to struggle with, so I would highly, highly encourage you to spend a lot of time with the practice problems for this section, because it is pretty challenging when you're first learning it.